All right, here we go, guys. Here we go. We're going to do partial sums of a sequence. Partial sums of a sequence really not too difficult to understand. We're just going to add up part of the sequence. That's what a partial sum of the sequence means. Sum means to add, partial means part, and we're going to add up part of the sequence. They're going to tell us how many parts they want us to add. The notation that we use is we use this letter S. Okay, so the letter S gives us, kind of signifies to us that we're summing up part of the sequence. So here it says S sub 1, which means you would just have the first term. S sub 2 would mean you'd add up the first two terms. S sub 3, you'd add up the first three terms. S sub 4, the first four terms. S sub n, all the way until you get to the nth term, adding them all up. Okay? And so S is the notation we use for partial sum. Here we go. Doesn't seem too hard. Let's go ahead and try this one out. So it says find the first four partial sums of the nth partial sum of the sequence given by a sub n equals 1/2 to the n. So they want us to find S sub 1. That means we're going to plug in a 1. So that's 1/2 to the 1, which is just a half. Then we're going to find S sub 2, which means we're going to take 1/2 to the 1 plus 1/2 squared. Well, we already know 1/2 to the 1, that's 1/2. 1/2 squared is 1/4, which is going to give us 3/4. S sub 3, well, that's going to be 1/2 to the 1 plus 1/2 squared plus 1/2 to the third. We've already done 1/2 to the 1 and 1/2 squared. That was 3/4. Now we just need to add 1/8, which is going to give us 7/8. Get common denominators. Multiply by 2 on top and bottom. Now S sub 4, the fourth, so finding this partial sum is going to be 1/2 to the 1 plus 1/2 to the 2 plus 1/2 to the 3 plus 1/2 to the fourth. Okay, so that's going to be, we've already done this part right here, which is 7/8. We're going to add then 1/16, which, because that's 1/2 to the fourth, which is going to be, get a common denominator, 15/16. So, if I were to write up these partial sums as a sequence, if I was to write them up as a sequence, look what I have. I have 1/2, 3/4, 7/8, 15/16. What do you notice about the bottom number? Well, it's being multiplied by 2 every time. Repetitive multiplication is an exponent, so we could say that the bottom number, so if I had any kind of, if I wanted to find the partial sum of any n, I could take 2 to the nth power. That would give me my bottom number. Think about it. 2 to the 1 is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. So whatever nth is, that's what I want to take 2 to the power of. Now look at the top number. It's kind of interesting. You could look at it and say, oh, 1 to 3 is 2, 3 to 7 is 4, 7 to 15 is 8. Okay. Yeah, so what are we doing here? Well, you could also notice that it's always just 1 less than the bottom number. So in other words, it's 2 to the n minus 1. And if you split these, if you kind of rewrote this fraction, if you kind of split it out and wrote it as 2 to the n over 2 to the n minus 1 over 2 to the n, notice I just kind of put both the top numbers over 2 to the n. That really, then this becomes 1, so that really gives us 1 minus 1 over 2 to the n. And that's what any partial sum of this particular sequence would be. So any partial sum would be given by 1 minus 1 over 2 to the n. All right, so that's partial sums. Hopefully that helps out. We're going to move to sigma notation and look for the next video. See you guys. Bye.